Hello MBA students. This video is going to show you how to do the first model from chapter 4. So you'll want to open the file advertising1.slxs from your student resources. Alright, so first of all, let's talk about naming the correct ranges. So we are going to grab this actual exposures and the required exposures and go ahead and name those two ranges. Again, go to formulas and the formula ribbon, and then do create from selection and make sure a top row is selected there. And we're also going to name the range number of ads purchased. So go ahead and select A19 through I19. Again, create from selection. This time left column will show. Hit OK. And the final one we're going to select is this total cost. Remember to select them, they have to be the same shape and size, so that's why we have to do it 3 different times rather than grabbing all of those and doing them at once. Okay. And now we will come over to cell G21 and type in range names used, and then we will go ahead and copy and paste. So go to use in formula, paste names, and then paste list. And now our list matches the one in your textbook, which should make it a little bit easier for you to follow on. Alright, next let's talk about where they came up with some of these numbers. Well, first of all, the viewers per show in each category is determined based on survey data that is sent out sometimes by the network, sometimes by other organizations. And then, of course, the more viewers that a show has, the more valuable the advertising time is on that show. The cost per ad would come directly from the company that, or from the broadcasting company. The total viewers is something that we can calculate, and I went ahead and did that before we started, but just to show you what I did is I did equals sum, and then I selected all of these. Okay, so this would be 21, which represents 21 million viewers, I believe. So then we can copy and paste that all the way over. And then the other thing is the cost per million exposures, and what we did here is we took the cost per ad and divided it by the total viewers, so that is B14 divided by B12, and again you can just copy and paste that formula all the way across. The number of ads purchased is our decision variables. This is what we are getting Solver to tell us the ideal numbers for to meet our constraints. So let's go ahead and mark these so that they are easy for us to grab and see later. Now we want to be able to calculate the actual exposures for each category. So what we are going to do here, we need a sum product because we need to know how many of, for instance, the Desperate Housewives ads were purchased, and then we multiply that by each category. So for this first one, so we're going to do Desperate Housewives times B6 is what it's going to amount to, but we do equal sum product, and our first array is going to be this men 18 to 35 because that matches the category here. So see, men 18 to 35, and we are working on the constraint for men aged 18 to 35. All right, number of ads purchased. Now, I am not having to put this as an absolute value because when you name a range, it is automatically an absolute value. However, if you did not name your ranges and you are just putting in the range as B19 through I19, the entire range needs to be an absolute value because you do not want it to adjust as you copy and paste the formula to other cells. You can go ahead and hit enter on that one. It is 0 exposures at this point because there's nothing in these cells, so anything multiplied times 0 is of course 0. So that's why all of these are going to be zeros. You are just plugging in the formulas so Excel can use them in Solver. If you put in values, then you would see these start to change. So you put in a value for Desperate Housewives, and it would then give you the number of viewers for each. And I'm just throwing in trial values. You do not have to do these. They are not meeting the constraints, and they have nothing to do with the solution to the problem. All right, so you can see that your formulas are working. Let's take a closer look at these formulas just to make sure you understand. So what this sum product formula did is it took, for cell B23, it took this cell, B19, times B5, plus C19 times, I'm sorry, it's B6. So it's B19 times B6 plus C19 times C6 plus D19 times D6 times E19 times E6 all the way to the end of the formula, which the last one would be I19 times I6. Then we copied and pasted all the way down. Because we didn't put this B6 to I6 as an absolute value, it shifted as you would have wanted it to do, and so now instead of referring to men 18 to 35, it refers to men who are 36 to 55 in this row 7, which is exactly what you wanted to do, but it still refers to the total number of ads purchased because this number of ads purchased here acts as an absolute value because it's a named range. All right, now we have to minimize, or we have to calculate the total cost because that's going to be our objective to minimize. And again, we do that as a sum product. And we need the cost per ad, which is going to be B14 to I14. And then array 2, again, is number of ads purchased. Okay. Now we should be ready to go ahead and run our solver. So go to your data ribbon and go to solver. Actually, I'm going to make sure cell B31 is selected. All right, go to solver, and our objective here is to minimize this number. So how can we get the exposure we need by spending the least amount of money? We are going to change the cells we identified earlier, which is B19 to I19. You could have also typed in the cell name. I just tend to find it easier to select them. All right, and then we are going to add a constraint. In this first one, our only constraint is that the actual exposures, which is B23 to B28, have to be greater than or equal to the required exposures, which is D23 to D28. Let's go ahead and press OK. Make sure you are on Simplex LP instead of nonlinear, and push solve. Okay, so now we have a solution that tells us we will be spending 1.8 million because this is in hundred thousands, and we're not going to purchase any ads on the Desperate Housewives or on Monday Night Football. We will be purchasing 8.7 ads on The Simpsons, 20.625 on Sports Center, none on The Real World, on 6.8 on Lifetime Movie, none on CNN, none on CNN, and then 6.3 and change on Law and Order. Now, notice that the ones we are purchasing movies on are not always the ones that are the least expensive. That's one of the advantages to this linear programming model, is that sometimes the obvious choices don't always work out best given your constraints. All right, let's look at a sensitivity report on this one. Okay. So the ones where we are at our limits for and just barely meeting the constraint are the men who are aged 36 to 55, the women aged 18 to 35, and the women who are I'm sorry. Yeah, we are just meeting the constraints on the men who are 36 to 55, and then all of the women. You see these, the cells B23 and B25 where the shadow price is 0. That means that we are more than meeting that constraint, and we could decrease the constraint and it wouldn't affect the solution. The shadow price here tells us that if we were to relax this constraint sum for men aged 36 to 55, we would be able to reduce our cost by an additional $15. Same for these women aged 18 to 35. If we were to relax that constraint, we would be able to save $10 for every unit that we relaxed. Sometimes instead of minimizing a budget, as we did in this example, an organization will want to maximize the bang that they get for a given budget. So in other words, they want to spend the entire budget, but they want to get the most product, or the most, in this case, they want to get the most exposures for a given budget. So here's how we're going to calculate that. So we want to maximize our excess exposures. So first we have to calculate the excess exposures for each group. So we do that by taking the actual exposures and subtracting the required exposures. And we do actual exposures minus required exposures because that gives you a positive number, whereas if you did it in reverse, it would be a negative number. All right, then we are going to sum these, and this is going to be the cell that we want to maximize. We are going to constrain our budget that it must be less than or equal to 2,000. Now, what I just did in cell C, where I put in the less than or equal to, that doesn't actually do anything in Solver. You have to put that in Solver itself. But let's go back. So our total cost is no longer our objective cell. Our objective cell is now these exposures. We are going to maximize those. We are still going to change the same cells, which is the number of ads purchased. However, we have to add a constraint, which means that this total cost has to be less than or equal to the budget. Go ahead and press OK on that. And again, make sure you're on Simplex LP and hit solve. So in the future, if you were going to present these two models to your manager, you would want to talk about the minimum amount you would need to spend, which is that 1.8 million, in order to meet your minimums for your required exposures. Then you might also discuss the extra bang for the buck that you could get if you would go ahead and use the entire budget of 2 million, and how you could have what amounts to 41 million extra exposures. All right. We've got one more thing that I need to show you on this one, and that is an integer constraint, because sometimes you can't buy partials. For instance, you might not be able to buy 3/100ths of an advertisement. It might be 6 or 12. And so sometimes that integer constraint changes the solver quite a bit. So let's go ahead and add that in. To add an integer constraint, you go to Add. You put in the cell reference, which is again the number of ads purchased, and then you set it to integer. Okay, and you don't have to put anything else in the constraint. Push OK and tell it to solve. Okay, and notice how that changed the values quite a bit in some cases for what you should buy. So it's not always really intuitive. So if you can't produce a partial model, you may need to consider, or buy a partial advertising spot, you may need to consider an integer constraint for your model. Hope that this has been helpful, and I will plan to keep producing these videos for you all. Have a great evening.